How do JavaScript engines optimize for loops? Imagine writing a simple loop that counts from 1 to 10,000. Now think about how a computer makes that happen faster and more smoothly. That's where JavaScript engines step in. They work behind the scenes to make loops run more efficiently. They do this by reducing the work needed each time the loop runs. For example, if you are looping over an array, the engine might store the array's length outside the loop. This way, it doesn't have to check the length every single time. This trick is called loop invariant code motion. It saves time, especially with large arrays. Another way engines speed up loops is by loop unrolling. Instead of running one iteration at a time, they do multiple at once. For example, instead of processing one item per cycle, they process 2 or 4. This cuts down on the number of checks and increases speed. Loop fusion is another technique. If you have 2 loops that go over the same data, the engine can combine them into one. This reduces overhead and makes better use of the computer's cache. JavaScript engines also look for work inside the loop that doesn't change. If you have calculations or function calls that give the same result every time, the engine moves them outside the loop. This way, it doesn't repeat the same work each time. Using simple for loops with counters is often faster than higher-order functions like map or for each. These functions are easier to read but can be slower because they don't give the engine as much control. Accessing local variables inside the loop is quicker than reaching for global variables or one's enclosures. Declaring variables inside the loop helps the engine optimize access. Early exits with break and continue are also helpful. If a condition is met, the loop can stop early, saving time. Modern JavaScript engines use just-in-time compilation. This means they turn your code into machine code while your program runs. They analyze the loop for predictable patterns, like fixed iteration counts or simple math. Then they generate faster native code and inline functions to avoid extra calls. In web development, these optimizations matter a lot. Caching array lengths, choosing the right loop type, avoiding heavy work inside loops, and combining loops all help your code run faster. Using local variables and early exits can also make a difference. Remember, while higher-order functions are easier to write, traditional for loops often give the best performance. By understanding how engines optimize for loops, you can write code that runs faster and makes your web apps smoother.